These are the things that every senior software developer needs to know about messaging. We're going to talk about 3 categories of messaging, why you should use messaging, some potential consequences of using messaging, and by consequences I mean bad ones. We're going to talk about some considerations of designing your application for the use of messaging. We're going to talk about some error conditions, and finally we're going to talk through some specific technologies that you can use. So these are the 3 categories of messaging conversation types. The first is direct messaging, or sending to a mailbox. In other words, you know the address or the destination of the message, and you can assume quite a lot of detail about that. And you would typically use this in a situation where you're performing a command on a far end. So you package up your information and you send it to the far end, and you expect something to happen at the other end. Another workflow is publish and subscribe, and this is often used when, or topics, and this is often used when you don't know the subscribers. So you basically have a topic, and that topic will send out a specific message type. So you'll raise this message type saying, oh, something's happened, and all of the subscribers will receive your message. So this is sometimes called broadcast or multicast, and you probably you would use this in situations where you don't know or care about whether or not the message has been delivered, or who receives the message. And the final kind of workflow, and this is sort of less commonly used, but it's a request response workflow. The reason to say it's less commonly used is because quite often we just use REST instead of using message passing. And I guess one of the reasons for that is that when you send a request and are expecting a response, you're sort of eroding some of the benefits that you get from using message passing. Not entirely. I mean, and one of the benefits you sometimes get is that you decouple the send and the receive from the application that's in memory. So you might receive a response about a message, a week later, and during that time your application has gone in and out of memory several times. It's on a different server or something like that. But yeah, so those are the 3 different workflow forms that you'll likely see out there in the wild. All right, so why would you want to use messaging? The first is to defer or to split up work. And that's helpful in a situation where you want to return control to a calling application or something like that. I think probably the primary situation for this is that you send some information from a user-facing application to a back-end application, and it isn't able to process it straight away. And that's fine. You just put it into a buffer or a queue or something like that, and it gets dealt with later. So we talked about deferring or splitting up work and segregating transactions, and that means essentially avoiding timeouts by splitting up the work. Allowing transactions to transcend, or allowing workflows to transcend process activations. And you could use these kinds of things to allow your application to be more robust in the face of errors. So it basically allows you, it gives you a technology to deal with retries even if your process goes in and out of memory. And then one thing that it's used for quite a lot is sharing data between applications, and these might be in the form of snapshots or updates or commands or notifications or that kind of thing. And sort of related to that is auditing. So you might have a notification that comes out whenever something happens, and you might want to just keep track of all of those notifications. You put them somewhere, and that goes into an audit log perhaps. So what are some potential negative consequences of using queuing or messaging in general? The first is delays, and you've got to accept this whenever you put a queue in to place. There's a reason why you're putting it there, and that's to avoid overwhelming a particular process, and while stuff's in the queue, it's not being actioned, so there might be another process waiting for it to be processed, and while that's happening, there's a delay. So when you have delays, you also might have timeouts, and that can happen whenever you're waiting for something and there's a limited time period that you wait. And most commonly this sort of thing happens when you're talking about a user-facing scenario. So you've got an API that you call from the front end, perhaps, it posts off a message, and there are some machinations in another related process that usually finish pretty quickly, but because there's a lot of contention or something like that, then it doesn't get action straight away, but the request times out, so there's nothing listening once it's done. And that can be okay, provided you design your system to tolerate that. The next thing that can happen is staleness, and this can happen when between the time that you send the message and you have to process the message, some other stuff happens. And so now your message is stale and it doesn't have current data. And there are some ways of dealing with this. Ultimately, it means that you may need to go and get a more recent copy of whatever data it's talking about. That's not a panacea either, partly because quite often to receive that, to go and get that extra data, it involves some messaging of some sort anyway, which, there'll be latency and delays associated with, perhaps smaller ones. So I don't think you can fully get away from this. You just need to design your system so that they tolerate a certain amount of staleness. So the next thing is parallel processing, and that's really great if you've got a lot of parallel work that doesn't interact with each other, and it can allow you to get a lot of work done in a short period of time. The trade-off for parallel processing is contention, and what that means is if you have a lot of parallel work on an object that only really tolerates having one thing working on it at once, or one operation and process at once, when those things, they have to wait anyway. So you get contention, and that means that you either need to wait, fail, or retry your messages. And I think probably the last negative thing that I can talk about today is multiple delivery. A lot of messaging mechanisms have ways of guaranteeing that a message is delivered a certain number of times, at most once, at least once, or so on. I think, if you ever want to deal with retries, then you're going to have to face that you're going to be having more than one copy of a message delivered, and perhaps out of order. These are some considerations that you want to take into account when you're designing message workflows. The first is idempotence, and what this means is that if you receive a message and you process it, and then you send the same message again, ideally your system would act in a way that it would only receive the message once. So it doesn't double up actions after what that message has. So it doesn't double up the activities after the message has been processed. orthogonality, which is it's related to that, and I think that this is helpful if you have multiple messages in flight. It can be helpful if there's no interaction between the act of processing those messages. So if you have something that adds 1 to a particular variable and another one that subtracts 2 from a specific different variable, then those things can be orthogonal, and perhaps they can be processed in any order, and it doesn't matter which order that is. If you can't get your messages to be orthogonal, and I think that this is probably true in almost all realistic workflows, then you have to decide what to do about messages arriving out of order. So that's the next situation is so I talked briefly about delivery guarantees earlier. Sometimes you don't get any delivery guarantees at all, but I think a lot of situations you get a guarantee that your message is delivered at least once. I think that in most cases, particularly if you want to deal with retries, then you need to accept that message is going to be delivered more than once, but perhaps you can build into your application mechanisms so that it is only processed on one occasion. And that essentially means that you're going to have to keep track of messages that have been processed and which ones haven't been. And so what this ultimately means is that you're probably going to have more than one copy of your message around the place, one in the queue and one in your data store, which says, this is the message I received and this is it having been processed or it failed or whatever. And that's okay. And the reason you would want to have the entire body of the message and not just a receipt is that you might want to perform some compensation. So I received the message, it had this particular information in it, but now I've received a message that was meant to have been processed prior to that, so I have to do a little bit of time travel and process the previous message first and then process the next message, and perhaps I need to know what the state was prior to doing that, so you might need to keep track of all of that stuff as well. So that makes processing messages a little more complicated than intuitively you might have first thought. You might have this picture in your mind that I've got the state and then a message will arrive in order and I just perform that message, process that message, and then it gives you a new state, and then that new state will process the next message and so on. But if you're getting them delivered out of order, then all bets are off really, and you have to contend with that. Let's talk about errors. So the first most common way of dealing with errors is retries. And I think, this is good. It's a good, robust way of dealing with it. There are some problems when you exhaust all of your retries. A retried message can get in the way of processing other messages and can cause the so-called poison message problem, which typically means that we don't necessarily retry messages an infinite number of times, which means that sometimes messages don't get processed if they fail over. That can mean that they land in an error queue, and quite often this means that you need a person in the loop to perform some manual sort of compensation. You might also want to log the fact that you processed messages and there's been an error. I think this is a pretty weak form of error recovery is logging, and quite often what it tends to devolve into is ignoring or forgetting that an error has occurred, which is a total strategy that people could use, and in particular for messages that are a little bit noisy, you might ignore or forget them. And the final strategy is, imagine you've got too many noisy messages, you could suppress some. Okay, so let's talk about some specific technologies. I've personally used RabbitMQ, which is it's pretty good. They have their own consistency algorithm, which they designed themselves, I believe, and has a proof associated with it. So it's a particular proof of consistency. It's called Raft. It's not the only consistency algorithm. I've also used SQS, which that's, we talked about the direct messages versus the broadcast messages, and they've got a different technology called SNS, which has the topics in it. SQS natively only supports messages up to a certain payload size, so quite often, and I've used in-service bus, which allows you to send a message with just a receipt in it that says, oh, the payload's over here in the S3 bucket, and that's pretty good for large messages. There's also Azure Message Queue, which is Microsoft's one. I haven't got much experience with that. MSMQ, which is the one that's built into Windows. This one is basically a point-to-point messaging. So if you want publish subscribe, you need to build that into your application and deal with that specifically. There's ZeroMQ is very popular. I don't have very much exposure to that. It is a pretty good choice if you are just working in C or C++. And then there are a whole bunch of middlewares. I talked briefly about in-service bus, which is the one that I've had exposure to. There's also Mass Transit, and I bet there's a fair few other ones out there. You could also roll your own broker. I think times past where this is the best option, but if you want a specific set of performance considerations or, storage or whatnot, then, this is still an option and you can still do that. Or, you could choose from one of the many other options. And, this is one that if you have a shared database, you could always just build your messaging on top of a table in the data store. And if you're using in-service bus, this is actually one of the transports that they allow you to use. So that's what I have for you this week. If you have any comments, or you liked it or you didn't like it, let me know in the comments, or like this or subscribe, and I'll talk to you next time.